Number 10 is similar to the problem in review packet A, where basically you're given some data and they ask you to find a sinusoidal regression for that data. But the only thing I added here, just to basically make us pay more attention to the details in each part of the problem, is two sets of data. So I have all the months here from January to December, so there's 12 months. But I also had the average high and the average low temperatures for each month. So not just the average high or low, I have both of them here. So the table is a little bit different than we're used to seeing, but pretty easy to still work with. So anyways, this is supposed to say number 12, so again, sorry about the typo. What I'm going to do is first go ahead down here and neatly graph our points. If we read the directions carefully, it says, using the data above, make a sketch of the average monthly high temperatures. So I'm not putting the low temperatures on this graph. So again, the reason I put the high and low one here is to just make us more keen to paying attention to the details. Don't answer the wrong question on your exam, answer the right question. So make sure you circle or highlight those key words, high temperatures. Okay, so anyways, I'm going to make an appropriate scale on my x-axis. So it makes sense to use, go up by ones, and I think I actually gave you 12 spots. So, 1 will be January, 2 February, 3 March, 4 April, and etc. Okay. Now I apologize for not leaving you quite enough room to label your x and y axis, but this should be labeled. We're talking about the time. And the units we're using are months. So try to squeeze that in there. And what we're going to use on the y-axis is just going to be the temperatures. And I forgot to put in the problem with the degrees that we're using. We're not using Celsius, we're going to use Fahrenheit. So make sure you label both of those. Now, we're going to go ahead and graph the points. Label the y-axis, and we're going to pick something that's appropriate. I just picked something that would fit nicely. I made every 2 dash marks represent 15. So again, I'm going to go up by every 2 dash marks, and each one's going to represent 15 degrees. You could have done it different as long as it's neat and it fits on the graph, and all of the spacing is equal. So if you went up by 10s, 10, 20, 30, that would be fine too. But if you do something like 5, 12, 14, 25, whatever, that's not going to make sense. So don't just put these values that you see, like 44, 47, 57, etc., on your y-axis. They need to be spaced out equally. That's part of one of the rules, when we're graphing. Anyways, this will be 0 down here. We know that. This will be 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75, 90, and 105. Plotting points is pretty easy. So again, we're only worried about the high temperatures. So just circle that to remind us for now. So the first month is 44, second month is 47, next month is 57. So go ahead, I'll let you go graph these as I finish mine. Okay, there we go. So a little tedious, but we've got it. Now moving on, it says, part B says, determine the equation of the curve of best fit for the data by using sinusoidal regression. Record the regression equation for the high temperatures, so I'll just denote that in red, as well as the low temperatures. I'll denote that in green. Then sketch the curve of the graph. So since I only put the average high degrees on the graph above, I'll only sketch the curve in for the average high. Okay. Anyways, in order to get our equations, we're going to go into our calculator. So this is similar to review packet A. I'm going to put my data points in, so I'm going to turn my calculator on. I'm going to go to Stat. I'm going to go to Edit. And I'm a little ahead of you guys. I already went ahead and put all of my data points in. I've already gone through and double checked, so I'll give you a second to catch up, but I'll explain what I did. I put my months in L1, my average highs in L2, and my average lows in L3. Now we normally don't use this third column, but I'm just going to show you a little bit of a shortcut so we don't have quite as much retyping to do later. Again, I just want to encourage you to pause and don't feel like you have to rush. Take your time, make sure you plug in the points correctly. Okay, so once you're done, you're going to hit Stat. You're going to go over to Calc, and we want the option that says SynReg or sinusoidal regression. I'm going to hit Enter. And now this is the different part that I don't know if we've really covered much in our class. I want the sinusoidal regression that models the data that was entered in L1 and L2, the months and the average high temperatures. So what I'm going to do now is type, I'm going to hit the second button, find L1 and L2 in our calculator, which is right down here for L1. I'm going to put a comma in, and also type in second L2. And what this is going to tell the calculator to do is to pull our data from L1 and L2 in order to calculate our equation. So I hit Enter. Calculator's thinking. Okay, so voila, we got our answer. We have y equals 23.3 sine of 0.5 x minus 1.97 plus 66.9. So take a second to jot that down. Again, I just rounded out to one decimal place. Now I'm going to do the same thing, but I'm going to figure out the sine regression curve for our average low temperature. So I'm going to hit Stat again. I'm going to go to Calc. I'm going to find my SynReg, hit Enter, but this time I'm going to pull the data from L1 and L3, our months and our average low temperatures. So hit second 1, comma, second 2, Enter, and it's going to give us the other equation. Whoops, I did the same thing I did before, I'm sorry. Let's try that one more time. Stat, Calc, SynReg. I think I said it right, but I typed it in wrong, maybe, I forget. But anyways, second L1, comma, second L3, not L2. Okay, there we go. So now we have our average low temperature equation. So I'll go ahead and write both of those down. The average high was y equals 23.3 sine of 0.50 x minus 1.97 plus 66.9. Our average low was y equals 21.6 sine of 0.53 minus 2.23 plus 50.8. Part C says identify the vertical shift of your low temperature direction, because again, I kind of made this problem just again to emphasize the importance of reading the directions. So we're only worried about the low temperature, and we're talking about the vertical shift. What is the significance of this value in terms of the temperatures of Dundalk? Well, the vertical shift is equal to that last number, 50.8. What's the significance, or what does this mean? That's just the average, or it's just the average temperature, or might even be better to say the median temperature because it's dead center. Most people would just say average, but typically in math we would say median if it's dead center of all the values, because again, if we go up to our graph, oh, I'm sorry, we didn't actually put that on the graph, but if we struck this line in there, 50.8, it's going to go directly through the middle of all our data points. But anyways, just know that it means the average temperature. That's what our vertical shift means. Part D says identify the amplitude of your high temperature. So the amplitude of the high temperature equation, the amplitude is just that first number, 23.3. So what that means is, I'll go back up to my graph for a second. I want to just sketch that curve in that we were told to do, I think in part B. I'm sorry, part B. So I just kind of drug my pen on there, did some dots, have our curve in there. Again, what the amplitude represents, that 23.3 number, is if we were to strike our center line in there, or our vertical shift for our high equation, our vertical shift in the high equation, even if we weren't asked to really find it, is this value right here, 66.9. 66.9 is approximately right dead center of all of the temperature values. So again, this is like that median or that average temperature for the high temperatures. Okay. The amplitude is just the height. So just draw on some lines here. This distance right here is about 23.3. Same thing with this distance down here. It's also about 23.3. So the amplitude on the graph just basically is the range. If I take 23.3 and add it to 23.3, you get a range value of 46.6 degrees. So we know the range just means to subtract the highest from the lowest. This is just another way of figuring out the range by adding the or multiplying the amplitude by 2, or adding these two values together. If you look at the original problem there, the highest temperature was 91, the lowest temperature was 44. If you subtract those two to get a range, 91 minus 44. We're not asked to do this in the problem, just trying to make a point, make a little bit more of a connection to this. That gives you 47, which is pretty close to this value here, because again our equation was just approximation. Okay. So anyways, the amplitude is, what's the significance? It's half the range of our average high temps.